All right, so we're dealing with multi-step equations and how to solve them. And the first thing I want to get down is actually this little note right here. The process we're going to use to solve these equations is called, and I put in quotations, working backwards. Which is not necessarily, because I want to clear this up for all of us before we start working on these reverse order of operations. So get this down and I'll explain it through our examples. So the process we're going to use to solve these equations is called working backwards. That doesn't necessarily mean it's reverse order of operations, although sometimes it is. Okay, once you get that note down, go to page 157, and you see on example number 2 is the one we're going to start with. Can someone read that problem for me, Mrs. Guzman's? Can you read example number 2? Okay, Harper.
Mrs. Guzman's washing machine needs fixed. Since her machine is pretty old, she doesn't want to spend more than $100 for repair. A service call will cost $35 and the labor will be an additional $20 per hour. What is the maximum number of hours that the representation can work and keep the total cost $100?
Okay, so a very practical example of why you would need to come up with an equation, but what do we know about washing machine? Not only does it need to be fixed, but it's also old. So do you really want to spend a lot of money on an old machine? No. So she's going to spend, for her, a maximum of $100. And remember, guys, this is like 20 years ago. So money has lost its value, but $100 for repairs. And so we're going to set up a little equation. How much money is it going to take for that person to come out? Do you guys see how much it was? A service call is how much money? $35. So that's she's going to have to pay that to have someone come and look at it. And then it says, how much money will it cost per hour to have the repairman fix it? Per hour. 20, right? So she's also going to have to spend $20 per hour. And then we have one last piece of info. What's the maximum amount she wants to spend? So I'll put it here, $100 max. She does not want to spend more than that. Okay. Does anyone know what kind of equation they would get to figure out how many hours max she could use on, I'll put here example 2, she can use on this washing machine so that she doesn't go over $100? Well, how much is, okay, go ahead, Eli. Okay, you're going to use subtraction. Very good. You're going to use it. And to write our equation here algebraically, she's going to pay $35. And added to that, she's going to have to pay $20 per hour. Do we know how many hours that is yet? Nope. So I'm going to say $20 per H, or times H. H stands for the number of hours it's going to take. And she doesn't want it to go over $100. So that's the max she's going to spend. So she wants to find out, if I pay $100, how many hours will the repairman be able to fix it? And then that'll help her to make a good decision. All right. This is my equation. $35 for the service call, $20 per hour. I want it to only be $100 max. Okay, we're going to work backwards from this. We look at the variable just like we have been in the other examples. What's going on with the variable? What operations are going on with the variable? What's the first thing? It's first being multiplied by 20 and then added with 35, okay? And the reason I went over that is because I want you to realize the order right now is it's being multiplied and then added, right? So multiplied and then added. Now I have to work backwards to solve for that H. I'm going to work backwards, so I'm going to kind of show that. I'm going to deal with the addition first, then with the multiplication, okay? Now you don't have to write this down. I'm going to write it on all the problems because I want you to see what's going on in my mind and then what process you're going to go through. So what undoes addition? Subtraction. So I'm going to subtract $35 from both sides. because this is an equation we have to subtract from both sides, and we're left with 20h equals 65, because I took away 35 from both sides. Okay, I'm done with the addition, so what do I have to deal with now? The multiplication. What undoes multiplication? Division. So I'm going to divide both sides by what? 20, because I want to undo this multiplication, so I divide by 20, and I have to do that from both sides. And I'm left here with what? What's 20h over 20? It's just h, which is good. And then 65 over 20, that's going to either be a decimal or an improper fraction. Let's deal with the fraction form. What would this reduce to? Okay, 3 1/4, but what does this improper fraction reduce to? 13/4. What went into both of these numbers evenly? What number went into both of them evenly? 5, right? 5 goes into 65, 13 times 5 goes into 20, 4 times. So you're like, all right, Mrs. Guzman, you can have that repairman stay for 13/4 hours. She looks at you. Wait, excuse me? Okay, what does that mean as a mixed number? So how would I change this to a mixed number? Just divide, I'd get 3 1/4 hours. And you could say, Mrs. Guzman, you can have them out there for 3 1/4 hours, or about 3 hours, and that will hit your maximum of 100. So that's a good amount of time depending on the problem. Like if he comes back to her and says, oh my, it's this, and that. She's probably thinking in her mind, I can't do it, got to get a new one. If he says, it's just this, that's probably going to be fixed in less than 3 1/4 hours. She's going to make that decision. But that's the whole process of working backwards. And now we're going to work it out with other examples. So, example number 3 on page 158. Example 3. We're going to do A. And I'm going to notice a pattern with these problems, and then I'm going to show you how that pattern doesn't always hold. So here we have y over 5 plus 9 equals 6. So what I'm doing in my head is I'm asking myself, what's going on with y? So can anyone tell me what's going on in order to y? What's first happening to y and then what's happening after? James, do you know what's happening to y? Divided by 5, so it's being divided. And then what else is happening to it next? It's being added. So it's being added. Okay? We're going to have to undo that. So to undo that, we're going to work backwards. We're going to start with adding, or get rid of the adding, and then get rid of the division. So what do I have to do to both sides here to get rid of that adding? Taylor? What am I going to subtract in this case? Subtract 9 from both sides. So that's going to be my first step. Subtract 9 from both sides. I'm left with y over 5. This became 0. And that's negative 3. 6 minus 9 is negative 3. All right, and then how do I undo the division? What do I have to do? Kendall? Multiply what by both sides? You're going to actually just multiply by 5. Yeah, if you multiply by 5, what's going to happen with this 5 and that 5? Do you guys know what happens here? They cancel out. They become 1 over 1. And 1 times y is y. What's negative 3 times 5? Negative 15. Y equals negative 15. Okay? Now, I'm looking at the answers thinking, okay, I got an answer. Great. But does it fit up here at the beginning? Well, what's negative 15 divided by 5? Negative 3 plus 9? 6. That has to be my answer. All of these problems with solving, and in fact, on your quiz on Tuesday, all the problems I'll give to you can be checked by you to see if it's right or wrong. So some of them are going to be easy like that. You can check them back in there. And some of them you might have to work them out again to check it if you want. It's your choice. I'm not going to force you, but I would recommend it, especially if you have time. Okay. B, I have D minus 2 divided by 3 equals 7. Now, what I've noticed in the first two examples is that, do you guys know anything about order of operations? Do you guys remember anything about it? Have we been doing basically reverse order of operations? So here we're supposed to multiply then add, but then we add then multiply or deal with the addition multiplication. Here we usually deal with this first then that. So we've been working backwards. You guys understand that? Reverse order of operations. But this problem is a little bit different. Somebody tell me what's happening to D in order. What's happening to it? Yes, Riley? What do you think? What's happening to D? It's first being subtracted, and then it's being divided. So that's what's happening to it, and I'm going to have to work backwards. Oh, Mr. A, I am doing order of operations. Wait, do you reverse the order of operations, or do you go with the order of operations? And my answer is this. You have to look at the variable, see what's happening to it in order, and then go backwards. And sometimes that's order of operations, sometimes that's reverse order of operations. Basically, don't think too hard about order of operations when you're working it backwards, okay? All right, so what do I have to deal with first? The division. So how do I undo the division by 3? I have to what, Harper? Multiply by 3. So I'm going to multiply both sides by 3. These 3's, what happens to them? Cancel out. Boom, boom. So I'm left with D minus 2 equals 21. What do I do with the subtraction, Owen? How do I undo the subtraction of 2? Add 2 to both sides. Yep, just add 2 to both sides. And I am left with D equals 23. Okay, that's what I think my answer is. Is it truly my answer? All right. You see the original problem from here to here? What's 23 minus 2? 21 divided by 3? 7. So is that the right answer? Yes. And again, you can check it. So that is our correct answer for this example. All right. I'm actually going to do a couple examples from page 159 because these are the ones that get tougher. Like these I hope you guys can get. But on page 159, can you guys look at number 10? This is where people get a little bit stumble because they are just written a little bit differently. So this one is number 10, 2/9 b minus 6 equals 14. Okay, so we're gonna start off doing the same thing we did on the other two. What's happening to b? It's being what? Multiplied, and then it's being subtracted. Okay, so I'm going to deal with the subtraction first, then I'm going to deal with the multiplication. So what do I add to both sides? 6. So I'm just going to add my 6 to both sides, and I'm left with 2/9 b equals 20. Okay, good. So far, so good. This is where people have trouble, and I'm going to make it easier for you. If you remember yesterday's lesson, this is a problem you would get. Can somebody tell me how to undo this multiplication? 2 ways to do it. One way's, they're both correct. One way's a little bit quicker than the other. And you guys like quick, I hope, right? I'm okay with the long way. Okay, what are my 2 options here? So how do you undo multiplication normally? You divide, right? Can I divide both sides by 2/9? And that would work out. But what else can I do? So I'm asking you guys, what else can I do here to get rid of the 2/9 being multiplied? Multiply both sides by the reciprocal of 2/9, which is 9/2. And I'm going to do that to both sides. Multiply both sides by 9/2. Wait, Mr. A, I thought you were supposed to work backwards and undo things. Is my multiplying by a reciprocal undoing this multiplication? Yes, so it's allowed. And that's what is nice about multiplying. What's 9/2 times 2/9? It's 1. So I'm left with b. And then here, to help yourself out, what I'm noticing on some of the papers, and I'm trying to help those who maybe are not sure, when you're multiplying these 2 fractions, you could do 20 times 9 is 180 over 2. 180 divided by 2 is going to give me 90. But this one's an easy example. I'm going to go ahead and cancel out some things. 20 over 2 is 10 over 1. And so now I have an easier problem. I get my answer of v equals 90. And the reason I do that is because you've noticed already that these multiplication problems sometimes have like double-digit numbers, things that can't be easily multiplied, and so make it easier by canceling first before you multiply. Is V really 90 though? I don't know. What's 2/9 times 90? Or what's 2/9 of 90? 20? 20 minus 6. Check, it works. We checked it out. It has to work. So remember, when you have fractions being multiplied, you can undo it by multiplying by the reciprocal. And then the other example I wanted to go through was number 11. And oh my, this is tough. Why do they write them this way? Okay, well, I'm going to treat it the same way I did the other ones. All right, what's happening with A? It is being, go ahead, divided. It's being divided by 7. And then what else? This is a tricky one. It's being, or it is subtracted from. And I'm actually going to put subtracted from. Isn't this a little bit different than your other examples? Last examples may have been like A over 7 minus 3. But this one's saying 3 minus A over 7. That's different. There's no commutative property of subtraction. There are a couple ways you can deal with this, but I'm going to show you one way here. How do I deal with this subtracted from aspect? How do I do that? What do I have to do in this case right here? Be very careful. How do I get rid of that 3 is what I'm asking. Anybody know? Wait, it is being subtracted. Oh, subtract 3. Let's see what happens. What's 3 minus 3? 0? Doesn't that cancel that out? But you got to make sure you know what's left behind. So what was left behind on the left side? Someone answer that. What's left behind? Be very, very careful. Negative A over 7, or negative A over 7 with the negative sign here, or even down there. We'll deal with that in just a bit. And that equals negative 5. All right. If you can get to that part, you're pretty much good. What do I do to get rid of that division? Well, what did we do last time? You multiply by 7. Okay, so here these 7's cancel. I'm still left with negative A equals negative 35. Oh, nice. I go with the opposite of A is. Do I want what negative A is? No, I want what positive A is. So what's positive A? If negative A is negative 35, what's positive A? 35. The sign switch on both. A is 35. So this is the tricky part right here, and I wanted to go over it because you're going to see problems like this again. Okay? Okay, and then last one, and then I'll let you work on the homework for the rest of the time. All right, number 13. On the same page, number 13. P minus negative 5 divided by negative 2 equals 6. What's happening to P? It's being subtracted with a negative. Sorry? So is this what you're thinking here? Oh, and here's the thing. If you're looking at this and saying, can't you rewrite this? Can anyone rewrite this using addition? It'd be P plus 5. So I'm going to rewrite this problem. Can I deal with that now? I can deal with that very easily. What's happening to P? It's first being added now, and then it's being divided. And I'm going to reverse that order. So what do I multiply both sides by? Negative 2. Okay, the negative 2's cancel each other out. What's negative 2, by the way? What's negative 2 divided by negative 2? Give me the full answer. Negative 2 divided by negative 2 is positive 1. Good. So they cancel each other out. I'm left with P plus 5 equals negative 12. And then what do I do to both sides to get rid of that addition? Subtract 5 from both sides. And I'm left with P equals negative 17. You can rearrange things to help you to understand the problem better before you even start adding, multiplying, dividing, subtracting. as long as you're doing it properly. Am I allowed to change p minus -5 into p plus 5? Yes, so do it if that helps you out. If you didn't do that, you would have to either, and this is, even saying it's confusing, after you multiply by -2, get rid of that, you'd have to add -5, or you'd have to subtract 5. And I'm just like, good luck on doing that correctly or clearly. But if I change it like that, it's super easy. And you just go ahead and work that out. Okay, your homework tonight, let me get that here. And you can start working on it now. You have the rest of the class time. I'll give you more time also at the next hour. Is going to be 17 to 38 and 49 to 56. You guys are very well paying attention. I appreciate that. And I hope it helped you out to understand what you're doing. My numbers got cut off here. Okay, just a 161. You have to show your work again. You got to show your steps. And some of them are decimals. None of them will go past the hundredths if you work it out as a decimal. And I would prefer getting it into a fraction form rather than decimal form. That tends to be easier. We're going to go through the second part later.